The sum of the ages of two friends is 26 and the difference is 2. Find the ages of both friends. We can solve these types of linear equations where the number of equations in the system of equations is equal to the number of variables using Cramer's rule. So in this session, let's understand how to find the solution of two simultaneous linear equations in R2 using Cramer's rule. Suppose we want to solve the system a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0 in R2. Now we suppose that a1, a2, b1, b2 are all non-zero. Then multiplying the equation a1x plus b1y plus c1 is equal to 0 by b2, we get a1 b2x plus b1 b2y plus b2 c1 is equal to 0. This is equation 1. Also, multiplying the equation a2x plus b2y plus c2 is equal to 0 by b1, we get a2 b1x plus b1 b2y plus b1 c2 is equal to 0. This is equation 2. Subtracting the second equation from the first, we get a1 b2 minus a2 b1x is equal to b1 c2 minus b2 c1. If a1 b2 minus a2 b1 is not equal to 0, then x is equal to b1 c2 minus b2 c1 over a1 b2 minus a2 b1, which is equal to determinants of b1 c1 b2 c2 over a1 b1 a2 b2. Again, a1x plus b1y plus c1 is equal to 0 implies that a1 a2x plus a2 b1y plus a2 c1 is equal to 0, a2x plus b2y plus c2 is equal to 0 implies that a1 a2x plus a1 b2y plus a1 c2 is equal to 0. We get a1 b2 minus a2 b1y is equal to a2 c1 minus a1 c2. If a1 b2 minus a2 b1 is not equal to 0, then y is equal to c1 a2 minus c2 a1 over a1 b2 minus a2 b1, which is equal to determinants of c1 a1, c2 a2 over determinants of a1 b1 a2 b2, which is equal to minus determinants of a1 c1 a2 c2 over determinants of a1 b1 a2 b2. Thus, if a1 b2 minus a2 b1 is not equal to 0, the unique solution of the given system is given by ordered pair xy is equal to determinants of b1 c1 b2 c2 over determinants of A1, B1, A2, B2 minus determinants of A1, C1, A2, C2 over determinants of A1, B1, A2, B2. This formula is known as Cramer's rule. If A1, B2 minus A2, B1 is equal to 0, but B1, C2 minus B2, C1 is not equal to 0, or C1, A2 minus C2, A1 is not equal to 0, then the solution set is empty. Now, suppose A1, B2 minus A2, B1 is equal to B1, C2 minus B2, C1, which is equal to C1, A2 minus C2, A1, which is equal to 0. Since A1 is not equal to 0, A2 is not equal to 0, we can take B1 by A1 is equal to B2 by A2, which is equal to K, and C1 by A1 is equal to C2 by A2, which is equal to P, where B1 is equal to A1K and C1 is equal to A1P, where B2 is equal to A2K and C2 is equal to A2P. Thus, the given system becomes A1X plus A1K times Y plus A1P is equal to 0, A2X plus A2K times Y plus A2P is equal to 0. By dividing the first equation by A1 and the second by A2, we get the same equation, which is X plus KY plus P is equal to 0. The solution set of the systems is set of ordered pair XY such that A1X plus B1Y plus C1 is equal to 0. Thus, in this case, the system has infinitely many solutions. For the equations, if A1 is equal to KA2, B1 is equal to KB2, C1 is equal to KC2, where K belongs to R minus within floral braces 0, then the two equations are called identical. Two non-identical equations in R2 have a unique solution. If A1B2 minus A2B1 is not equal to 0, and in case of A1B2 minus A2B1 is equal to 0, then the solution set is empty. Let's summarize. In this session, we have learned how to find the solution of two simultaneous linear equations in R2 using Cramer's rule. Cramer's rule is named after Gabriel Cramer, 1704 to 1752, who published the rule for an arbitrary number of unknowns in 1750. Colin Maclaurin also published special cases of the rule in 1748 and possibly knew of it as early as 1729. We will learn about more facts, applications, and other interesting mathematics concepts in our upcoming sessions.
Keep imbibing. We believe in you.